So we just have finished this. This has been in the lab up until a couple of weeks ago. And a couple of weeks ago, we went to the New England School of Acupuncture, and we collected some of our first field data. And so I have a couple of, these are two episodes. This one on the left is a TCM tonification technique at liver 3. And you can see, I don't know how clearly you can see these, how well the colors come out, but you can see there's a nice even, this depicts sort of on the motion side, a nice even back and forth rotation. And you can see that they're also, with the red line, going in and out very evenly with the needle. So they're rotating and going in and out very evenly. And at the bottom, you can see what's happening on the force side, where there's not a lot of torque or rotational force grabbing the needle, but there is quite a bit of axial force in and out. And now compare this to a Japanese tonification technique at the same point, and you can see that there's a lot less amplitude. In other words, a lot less motion in this particular example, but there's still quite a bit of in and out force being generated. So it gives us a tool to begin comparing things. And here's a couple of more pictures. Japanese sedation at spleen 9. Can you guys see those colors pretty well, or do they show up from your perspective? Good. So you can see that the amplitude, this person isn't rotating the needle much at all, but they're vibrating it up and down just a little bit. But what's interesting, and a fast frequency, you can see how the frequency is very rapid. And here you get to see how there is a bit of force being generated even with that small bit of amplitude. And once again, on the TCM tonification of stomach 36, now this is an interesting waveform because we've just started to quantify these things. And as you can imagine, we want to turn these pictures into quantities that we can analyze. And so it's pretty easy to analyze, for example, the average amplitude or the average frequency. But when you look at the waveforms of this particular manipulation, you can see what's going on here is sort of a fast out and a slow in technique on the motion side here. And you can see that just calculating the average frequency wouldn't capture that. So we're working on ways to calculate or quantify the waveform shape to help us quantify that aspect of needling as well. So what have we learned? And we're in the learning phase. Obviously, this is brand new, and we're introducing it to you because we want you to help. Well, we've learned that we can quantify needling, and that's exciting because it'll help us to generate hypotheses that can be tested. We've learned, I'll tell you, what surprised me, and I knew this, but I wasn't prepared for how much, was that needling is way more variable than we expected. I was amazed when we went to NISA at just how different everybody's techniques were. And these were veteran practitioners from the same school or the same area, but there was a lot of variability. And it made me realize we need a much better needling vocabulary. I felt like, you know, you've heard this sort of little thing about the Inuits and how they have 100 words for snow. They don't just say snow and sleet. And I realized, oh my goodness, tonification and sedation is like saying snow and sleet, and there are so many subtleties and differences in what's going on. Does it matter? I don't know. That's where it's up to you guys. This was an SBIR grant, which means it was a grant to develop a tool, a translational tool for people like you to use. So we're hoping that schools and researchers and clinicians will use this technology to begin investigating and exploring. Does needling matter? Is one technique better than another for a different condition? And the possibilities are up to you. So I want to obviously acknowledge our support, NCAM grant, SBIR grant, and I want to acknowledge our team as well, because this has been several years in the making, and a lot of engineering work and thought went into it. Thank you.